Welcome to the demonstration of CodeBot debugging capabilities inside RemObjects Fire. I'm going to walk through a small macOS application and use CodeBot to investigate several broken behaviors in a complete debugging session. We'll intentionally work with a project, investigate its behavior, identify the root causes, apply fixes, verify the results, and confirm that the application is working correctly. The goal is not just to fix a bug. The goal is to demonstrate how CodeBot can act as a debugging assistant, helping us understand code, inspect runtime behavior, and validate our fixes directly within the development environment. Let's begin. This project is a small library management app. It tracks books, members, active loans, returns, renewals, reservations, and reports. The main logic lives in the library class. At a glance, the application appears to do the right things. We can see it in action. A normal circulation operations seem to work. The first issue I want to focus on is in the borrowing logic. This application clearly defines a maximum borrow limit. That means once a member reaches that limit, further borrow attempts should be rejected. Let me show what's happening here. I have a predefined script that will do borrowing of several books for a specific member. Even though the limit is set at 3 maximum items and this member already has 1 book reserved, the system allows us to reserve 5 more books. That makes 6 in total. And at this point, the reason is not obvious just from observing the code. The constant exists, the feature appears to be there in principle, but the actual runtime behavior does not match the intended rule. So this is where I ask CodeBot to help investigate. The plan is to set targeted breakpoints inside the borrowing logic, run the application under the debugger, reproduce the failure, inspect the live values involved in the limit check, and determine exactly why the application keeps allowing extra borrows. Let's see how CodeBot works here. Rather than explaining how to solve the problem, I simply describe the issue and let CodeBot take over. It immediately creates a debugging plan, identifies the most likely location of the bug, and starts gathering runtime evidence. The first thing it does is place breakpoints in the relevant methods. Since these actions affect the debugging session, Fire asks for my approval before proceeding. Next, CodeBot launches the application under the debugger. When execution stops at the breakpoint, it begins inspecting the application's live state. Instead of relying only on source code, it evaluates expressions, examines local variables, and checks the values that determine whether the borrow request succeeds or fails. The collected runtime data quickly reveals the problem. The application is counting every historical borrow of the same book, instead of only the books the member currently has checked out. With the root cause confirmed, CodeBot explains exactly what it found and proposes a targeted fix. Before making any code changes, it asks for my approval. Once approved, it updates the implementation to use the member's active borrow count instead of the historical total. After applying the change, CodeBot automatically builds the solution to verify that the project still compiles successfully. It then attempts to perform a second debugging pass to validate the fix. In this case, the application exits before the scenario can be reproduced automatically. So CodeBot clearly reports what was verified, what evidence was collected, and what remains to be confirmed. Finally, I run the application again and repeat the same borrowing scenario. This time, everything works as expected, confirming that the issue has been successfully resolved. In the next phase of working on the application, I want to minimize the number of such failures and to cover this functionality with unit tests that account for various corner cases in the application's behavior. I'm asking CodeBot to take ownership of a complete testing workflow. The prompt isn't just asking it to write unit tests. It needs to analyze the existing code, understand the borrowing rules, create a dedicated test project if necessary, compile the solution, run the tests, fix any issues it discovers, and continue until everything passes. Before making any changes, CodeBot presents its implementation plan for approval. It explains how it will inspect the project, verify the current implementation, create the test infrastructure, build the solution, and validate the results. After approval, CodeBot begins exploring the project. It first verifies the current solution structure, checks whether a test project already exists, and analyzes the borrowing implementation to understand the expected behavior instead of making assumptions. Since no test project exists, CodeBot decides to create one from scratch and integrate it into the existing solution. While creating the new project, it encounters a couple of issues with project generation. Rather than stopping, it recognizes the cause, adjusts its approach, verifies that the required files were created successfully, and continues automatically. Next, it generates a comprehensive test suite covering successful borrowing limits, unavailable books, invalid members, invalid ISBNs, duplicate borrowing attempts, state updates, and several additional edge cases it identified during analysis. With the tests in place, CodeBot adds the new project to the solution and compiles everything. Wow! The build succeeds on the first attempt. The next step is executing the test suite. The first run fails because the executable is located in a different output path than expected. CodeBot inspects the build output, locates the correct executable inside the macOS application bundle, and reruns the tests using the correct path. This time, every test passes successfully. I had expected that I would have to request another round of debugging to identify issues with the app, but the test didn't reveal any new errors, which is great. When checking the contents of the borrowingtests.swift file, looks like that all required test fixtures were implemented in a correct way. Finally, CodeBot summarizes the completed work, including the new test project, the files it created, the 12 unit tests it generated, the successful build, and the passing test results. Instead of only generating code, CodeBot completed an entire development workflow, from understanding the existing project and creating test infrastructure, to compiling, executing the tests, resolving execution issues, and validating the final result, all without requiring additional guidance. The CodeBot is available for use inside RemObjects Fire for macOS, inside RemObjects Water for Windows, and we are releasing the brand new coding assistant for Delphi that could be integrated into the RAD Studio. This is just one example of what CodeBot can do. We'll explore more features and real-world development scenarios in the next tutorials. Thanks for watching, and happy coding with CodeBot!